let's deal with one more example here. This time we're going to deal with our tangent function. There's a shift here, vertical shift. We've got a change in period, and we've got a change in our vertical stretch. So we want to put all these aspects of our graph together and figure out what's going to happen. So I always kind of go back as a reference to my basic y equals tangent of x function and think about what happens with that. Right? When I had y equals tangent of x, I know that this is the kind of function that the argument x would show one cycle on the interval from negative pi over 2 to positive pi over 2 when I wanted to find my vertical asymptotes. So how can I use that here? Well, one way that I can use that right away is that I note that my argument here is x over 4. So I'm going to take my argument of x over 4 and I'm going to set it between negative pi over 2 and positive pi over 2 in order to get the location of two vertical asymptotes right away. So if I do that, I would have to multiply each side by 4 in order to isolate x. And that's what I'm after right here. So to isolate x, multiply each of these values by 4. What happens? Well, 4 times pi over 2 is going to be equal to 2 pi. So we've got negative 2 pi to the left. And to the right, we're going to take pi over 2 times 4. That's 4 over 1. 4 divides by 2, leaving us with 2. So we're going to have positive 2 pi off to the right. So our graph, however we mark it out right here, and I'll spread this out a little bit so that it looks more 2 pi-ish. Here's 2 pi, and here's negative 2 pi to make up one fraction. These are the locations of vertical asymptotes. So at the vertical asymptotes, we've got one at negative 2 pi and one at positive 2 pi. All right, so now we want to look and see what's going to happen within. Well, generally speaking, the way we do it is that if we're setting up key points within one cycle of the tangent function, we start with a vertical asymptote. We end with a vertical asymptote. And then we're going to see what would happen in between. Now, normally, for the tangent of x function, what would happen is that we would go halfway between negative pi over 2 and positive pi over 2 and find that we had a 0. But everything's being shifted upwards by 1. So instead of 0, what would happen right here is I think about what I would normally get at the halfway mark. In this case, halfway between negative 2 pi and positive 2 pi is 0. And then I'm going to add 1 to it. Now, that doesn't work with the vertical asymptotes, obviously, because a vertical asymptote plus 1 is still a vertical asymptote, right? That doesn't change anything. But how about the halfway points? Well, 1/4 point right over here to the left is at negative pi. Normally, that would pass through 1. But because we've got 1/4, it's going to pass through 1/4 times 1 plus 1 more. And so that's going to actually pass through 5/4 in the y direction over here. And at positive pi, it would be, we're going to take 1/4. Let's go back over here. Let's make a quick correction. Yes, I caught it. Normally, the tangent function, this is why I should draw the tangent function so that I recognize the basic cycle right here. The basic cycle between the two asymptotes would go at negative pi over 2, positive pi over 2, quarter cycle below the x-axis, halfway through the origin, and then up through. So in this case, normally, at my 1/4 period to the left, I'd be taking 1/4 of negative 1. And then adding 1 right here. So that means I'm going to pass to the point 3/4 when x is equal to negative pi. So here's negative pi right here. And then pi, we're going to have 1/4 times positive 1 plus 1 That comes out to be 5/4. So at pi, we're going to get up to 5/4. So let's see, how should I mark my axis? Well, in this case, let's make each of these marks equal to about a half. So here's 1, here's 2, here's 3. Of course, here would be -1, -2, and so on. I leave myself a little bit of room so I can work with this. We're seeing that in between our vertical asymptotes, to the left at -pi/2, we're going to be at 3/4. At x equals 0, we're going to be at y equals 1, and at x equals pi, we're going to be at 5/4. Oh, interesting. So this graph is going to come up along the vertical asymptote through our 3 points and then head off towards positive infinity. Now, I suppose another question might be, well, how are you getting all of these values that you're graphing? Well, right now I'm kind of estimating what the graph should look like after I've done making the picture, but really one thing that's kind of helpful to note is that this +1, it's kind of like as if I have the center axis just everywhere shifted up by some amount 1. If I go 1/4 above and 1/4 below along the y-axis, I'm going to see that my quarter points occur on this graph of tangent. So we can use these facts to help us get a good graph of something like a tangent, of something like a cotangent. We might want to know something about the domain. We would note right here that tangent of x normally would not equal odd multiples. Remember this, odd multiples of, or 2n plus 1 multiples of pi/2, right? But the argument in this case is the value x/4. So in order to get x by itself, we multiply both sides of the inequality by 4, and we get 2n plus 1 times pi. And so our domain is the set of all values of x such that x is between. X is not equal to x times 2n plus 1 odd multiples of pi. And you can see that's kind of what's happening here. Oh, wait a second, where did we get that right? Pi/2. Pi/2. No, we made a mistake, right? Because when we multiply by 4, that means we have to take odd multiples of times 4 times 4 of 2 pi. Ah, here we go. Yeah, right. So 2 pi, that's 1 times 2 pi. If we go 2n plus 1, that would be like 3 times 2 pi. So the next one's going to occur at 6 pi, and so on, right? Our period of our function is equal to 4 pi. How do we know? Well, remember that the period is always found by taking pi and dividing it by b. So our period is equal to pi/1/4. That's 4 pi. All right, so we can see that all of these things are verified within our cycle, and so this is what our graph is going to look like.